everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got McLeod who has just completed the course ROS 2 Basics with Python. So today you'll be giving us a presentation of that. So as always, we'll begin by seeing a demonstration on the real robot and then we'll get into the details of how he did his project. Alright, so I'll now hand over the floor to him so that he can begin. Alright,
Okay.
whenever you're ready.
Thank you. First, I would like to express my gratitude to the Construct team for providing me with this incredible opportunity to learn robotics through this intuitive and engaging platform. This is my first course, and I'm eager to continue my journey in robotics with this platform. The ROS 2 Basics in 5 days course has been highly interesting and has significantly enhanced my understanding of ROS 2. In this presentation, I will explain how I developed my project, a world finding and following robot using ROS 2. For this project, I created 2 ROS packages, and we have the world follower interfaces and the world follower. Inside the world follower interfaces, we have 2 folders. So this package contains the interfaces for communication between the nodes. We have the action folder. The action folder defines the odom record action for recording odometry data. So we have the odom record action. And the second folder is the SRV. The SRV contains the find wall service for locating and align the robot with a wall. And we also have the messages follower. That's a topic that includes the loop completed message, which is published when the robot completes a full loop.
Okay.
The second package is the world follower. This package contains the core logic of the project and consists of 3 nodes. So we'll give more details about the nodes. The first one is the find wall services node. This node, the goal of this node is to locate and align the robot with a wall. The state rotate the robot to face the nearest wall using ladder data and approach the wall until it is 30 centimeters away and align the wall to the robot right side. The other one node is the wall following node. This node enables the robot to follow a wall at a constant distance. The logic used laser scan data. If the robot is too far from the wall, it turns right. If the robot is too close, it turns left. And if the robot is at the correct distance, it moves straight. Okay, so the last one is the odom recorder. So these nodes record the robot odometry, its position and its orientation, and the text when a full loop is completed. So it starts recording when called by the world following nodes, and continuously stores position, and stop when the robot returns to its starting position, and publish the loop completed message and return the list of recorded position. Before diving into the code, I will showcase a live demonstration of the robot in action. This will illustrate how the nodes work together to achieve wall finding, wall following, and loop detection. So
Okay.
we will do this. a bit slower, but yes.
What's going on there? Is it constantly looking for the wall, or
Yes, looking for it's the word following.
okay?
No. So it will follow the wall and stop here, I think.
Did you program it so that it constantly has to check it's right like that, or I thought
Well,
once it finds the wall, it's supposed to go on straight until it encounters an obstacle.
yes. Uh, no, wait.
Okay, you can see as it gets out of the corner there, it constantly keeps checking to the right. Oh, maybe
Yes,
it's like
yes,
rotation to the right. Is it? Because obviously it does it is able to see that there is something to its right because of the lidar, right? But then why does it have
yes.
to rotate to the right constantly like that? What did you do, or did you? Is this the first time you seeing this happen, or did you
Oh
test?
no, it's it's not the first time. It's always do that. I think it's the in the wall following nodes that check the every time that check the distance. So
So
it,
how often
it
is that cycle? How often is it happening in your code? How often is it checking for the wall?
I think every time it goes straight, it check on the right side to make sure the for the distance with the wall.
Okay. Well, all right.
Now
I see. It could. Yeah, it could be.
better.
Yeah, I think it could be done better. It
Yeah.
doesn't have to be exactly visible, like physically that what it is doing. But even if the loop is running continuously, right, it's supposed to be happening smoothly, unless there is some type of uh,
Obstacle.
not really, some type of blocking that's going on within your code. So the service, when it's called to check for the presence of
Yes.
the wall, it stops the control loop that is responsible for controlling velocity
Yes.
commands. Is
Yes.
that
Yes. During development, I encountered issues with the fine wall service. So I think that's the issue. The fine wall services. Yes.
okay? So, um, what do you think you could have done better? If you had noticed that that is what's going on, what did you think could solve the problem, like abstractly?
Abstractly, I think there is a wait. There was an issue with the wait wait with the one finder.
Mm.
So I think the depending of where the robot is, uh, it can find the wall. So that's why I use a boolean in my wall follower. So I use a wall I use a first follow. So if I launch the services, so if it can find the wall, so the first follower will go through, the wall form will go through, and it will directly begin the wall following. So I think my wall folder is not really it's not well. Yes.
Okay, and let's go back uh, to your
Yes.
to the very top, actually, the wall follower, right? The wall follower
Follower?
script. Let's go to the very top. So
Yeah. Wait.
yes, go to the top of the wall following .py, right? Okay.
Yes.
Okay, we have a loop complete
Do
feedback.
you complete?
Yes, can we go to that function? I want to see what it's doing.
Okay. The loop complete is here, I think.
Yeah, loop completed callback. Okay.
Yes.
Okay, so can you explain to me a little bit how does this check to ensure that it has completed the loop?
Okay. It's with the odom recorder.
Mm-hmm.
The odom recorder that's here. It stores the position, and when the robot is the distance, we will see. Wait, I think it's here. When the so that's the yard difference. When the distance, I think wait, it's here. Yes, when the difference the is 0.5, so that will get the message completed full loop. So it will send
So is that radial distance, or so as long as you are within that radius to the starting point, then you can call the terminate.
Yes.
All right. Okay, so the other one is I want you to go to your callback that's responsible for publishing velocity commands. Can we have a look at that?
The command in wall following, or
yeah, in wall following, the one that's responsible for sending velocity commands to the control loop. Okay, it's the control loop. Okay, I see. All right.
So that's the twist. We have the twist if front distance.
So what I would like you to tell me is this control loop running in the same loop as the service, the wall finder service?
No.
So the wall finder is running in a separate thread. Is that what you're saying?
Yes.
Okay. Can you explain to me how you did that? How did you manage to split the threads in which each one of those is running in?
The wall finder.
Yeah, how did you manage to split the threads that the wall finder service runs in and the wall follower control loop runs in?
Okay, the wall finder is here, so the wall finder is just here. But with the wall finder, sometimes that didn't work. It depends of the position of the robot. So sometimes that doesn't work. So it's why in the wall following, I introduced Boolean is the first follow, so that can be true and false. If the find wall service return true, so the first follow will be false. And if it can find the services, the first follow will go through, and it will skip the wall finder services, and it will begin to follow the wall.
Okay. So that Boolean value keeps changing as your robot is moving. Is that right?
Yes.
Okay. All right. So, well, why am I asking about this? Right. I want to know. You have had as you went through the course, right? You do know about the presence of the different classes of callback groups we've got, right?
The what?
The callback groups, yes.
I don't use them in my project.
You didn't use them, right?
Yes.
All right. Do you understand them though? I wanna know first. Do you understand them?
The callback.
Yes, the callback groups. Yes.
No, I don't understand them very well, but I know we use them as method, and to just here in the project, I know you use them as method that we call in other methods. So yes.
Okay. All right. All right. All good. I was speaking about this because I think it could have helped your
The callback.
yeah, it could have helped how your robot goes around the lab, right? Because it would be able to either allow you to have the service running in a separate thread and then your main control loop running in another thread, so that your robot doesn't have to stop and check, or doesn't have this blocking behavior. Because I think what's making it stop and look is probably because of um
The
the
callback.
not the callbacks, but because of the fact that you have your wall finder, or the callback that's responsible for looking out for the wall, running in the
Okay.
same loop, same thread as the your main control loop, right?
Oh, okay.
So
Okay.
I would have to get into the details about your code, but this is what I'm assuming, right? So I'm thinking it could have helped you if you had understood a little bit more about the different types of callback groups and how you can ensure synchronization. But that's not a biggie at the moment. But
Yep.
do you still have any other um, code sections you want to show us and explain?
Um, no, I think it's. I think we see all the three codes, so the three
Mm-hmm.
nodes. I think
All right. So can we go back to the robot visuals?
what was the job? Okay.
Mm-hmm. Did it terminate, or
Yes,
it
it terminates.
stopped?
So it's total. That's the total traveled,
Uh-huh.
and the distance is here, and what that's up at the starting position. Yeah.
Right. Okay, that's wonderful. Wonderful. Okay. Job
Uh,
well done. I'm glad it managed to do that, and it didn't crash into the wall, right? So that's good. That's good. The other thing is, all right. I really need to think about it, but okay. Well done. I'm glad it managed to get to that point,
yes.
and so for a couple of questions, do I have any? Let me check. Not any at the moment. I think I've been asking as we go. All right, so congratulations, McLeod. All right, everyone. This was McLeod's presentation. So congratulations to him. And we'd like to encourage all those of you who would like to try the courses we offer certification on to do so, and you can come and present your work. So until next time, keep pushing your ROS learning. Bye bye.